Hello everyone. Hope everyone is doing fine. My name is Thomas, and first of all, welcome to the first ever International Python Data Science to Cybersecurity webinar. My name is Thomas, and it's great to have you here. So this webinar is part of our course on data science and cybersecurity using Python offered at CreArt. So for our webinar, this is first of the two webinar sessions where we'll be showcasing what our course is going to be all about, what it's going to contain, and it is the first time offering here by CreArt to India. And we'll be discussing a little bit on that towards the end of the session. So for our webinar this afternoon, so we will be looking at how to go about using machine learning and data science in order to detect cybersecurity threats. So the way that we have planned out is for this week, we'll be looking at developing a machine learning model to detect cybersecurity threats. And next week, in the next webinar, we will be looking at how we go about using the model that we have created in order to detect cybersecurity threats in real time. I'm sure that everyone is going to enjoy it. And so without further ado, so before we get on to the details, I'd like to go through a little bit of what we are going to do during this webinar, as well as give everyone a little bit of an overview of what we are trying to achieve through our course at CreArt. So first of all, a little bit about myself. So my name is Thomas, and I'm a researcher in cybersecurity and big data at the University of Gloucestershire. I did my PhD in cloud and big data security at the Glasgow Caledonian University from 2013 till 2016. And before that, I was involved in different variety of research areas in terms of data science and cybersecurity, and in recent times, a little combination thereof. So my research looks into how to go about using data science and machine learning to detect and mitigate various forms of cybersecurity attacks. So first of all, a little bit of a background. So as everyone knows, nowadays, cybersecurity has become one of the major talking points. And every week, if you look at all of the news articles, not a week goes by where we never miss out on any cybersecurity attacks. So just last week, there was a news article by the BBC whereby a group of Russian hackers tried to hack into the US and the UK and Canada's coronavirus research facilities in order to get the data concerning the treatment for coronavirus, which everyone knows is a huge risk. And in addition to that, we also, in recent times, just a few weeks ago, there was a news article which came out where the Sony PlayStation network was hacked once again by another group of hackers. And because from this hack, 93,000 accounts were illegally accessed as a result of this hack. And not to mention, as everyone knows, back in the 2016 US election, there was a huge allegation against the Russian government in terms of their attempts to help Donald Trump win the 2016 US election. So as with all things else, whether or not the allegations were true, we couldn't know for sure. But the long and short of it is, nowadays, with everyone on their smartphones, everyone on their computers, everyone doing pretty much every single aspect, from like learning new things to banking online, we have been using internet for far too long. And because of our dependence and reliance on on the internet, cybersecurity has become a huge issue with different forms of attacks being taking place, etc., etc. So when we talk about cybersecurity in recent times, so back in the day, when we talk about back in the day, we're talking about in terms of 5 or 10 years ago. Hacking is just a very simple activity. So you have a computer, you know how to program, you know the vulnerabilities of a target system, be it a MySQL server or a Internet Explorer, or so on and so forth. So it used to be quite simple. But nowadays, with the rise of mobile devices, with the rise of IoT devices, and pretty much all these smart devices, even our mobile devices, not to mention the Fitbits that we wear to track our health, etc., it has presented hackers with a rich environment, rich area of target on which to launch their cybersecurity attacks. So in recent times, the cybersecurity attacks have become increased, both in terms of scale. So now if we look at the cybersecurity attacks from like 10 to 15 years ago, the targets were only like hundreds or at most thousands of computers. But nowadays, it has become hundreds. The number of targets have increased to upwards of hundreds and thousands and even millions of targets. And not to mention the complexity has become far more complicated as well. So because back in the day, attacks were targeted towards a machine only. But nowadays, when we talk about the recent cybersecurity attacks, for those who have watched a TV show called Mr. Robot, which I'm pretty sure some of you will have seen, which is a TV show about hacker. So for those who have seen this show, you will realize that nowadays, cybersecurity attackers not just target the computers themselves, but they also target the human elements as well, thereby tricking people into disclosing their passwords, their usernames, so on and so forth. And not to mention, it has also increased in terms of frequency of attacks as well. Because if you look at the attacks from yesteryear, the attacks were like once every 2-3 months maybe, once every 6 months maybe. But nowadays, if you look at all these frequency of attacks, you get to see that the frequency has become larger and larger. So meaning that rather than taking months or weeks, it tends to be occurring on a weekly basis on average. And when we talk about cybersecurity attacks, typically the first thing that comes to our mind tends to be like, okay, so we are going to send a virus, right? So we are going to send a virus, and then we are going to steal all this personal information from us, from the target. I mean, I'm just referring from a attacker's point of view, of course. But when we talk about cybersecurity attacks, it is far more than just sending viruses and worms and malware. So when we talk about cybersecurity attacks, it ranges from simple phishing emails. You know, everyone has some kind of experience with phishing emails before, which is where you receive an email from someone that you have no idea, who is trying to send you some money that you have no idea that you existed, all in the purpose of, getting your personal information, account information, so on and so forth. So that is what is called a phishing attack. So that is from a security standpoint, cybersecurity standpoint rather, the phishing attack is the basic form of cybersecurity attacks, and then progressing on all the way to DDoS, which stands for distributed denial of service. So with distributed denial of service is where we try to make a website unusable and available. So we try to make as many connections, make as many connections to our target web server. For example, like if we want to stop, say, CreArt, which everyone knows, which is a website where you try to get the latest updates on cricket and cricket scores. If we want to target CreArt, just for the sake of this example, then we could use DDoS so that other cricket fans will not be able to use it at all. So that's what a DDoS attack is. all the way up to our usual suspects, sending malware, sending viruses, and in more recent times, ransomware. So it is because of the nature, the complexity, the frequency, and the scale of these attacks. Cybersecurity professionals are pretty much required by every single organization, regardless of their size and scale. It could be a small and medium enterprise, or it could be a large organization. So regardless of the size of the organization, regardless of the scale of operation, cybersecurity professionals are required for pretty much every single organization, every single industry in recent times. Which comes to our next point, which is about data science. So we know, based on the news that we have seen, so on and so forth, we know what cybersecurity is. But now, allow me to touch upon briefly about data science. So data science has become a bit of a buzzword in recent times, but more often than not, people, for the most part, don't really know precisely what it is. So from a technical standpoint, data science is all about extracting insights from data. So the name is although the name sounds very fancy, but if we put it in a very simple terms, it's all about extracting information from data. So as everyone knows, data is all about numbers and figures and characters, etc. But what we want to do is, given its collection of data, we want to understand what is going on. Data science was and still is used quite extensively in the financial sector, particularly in the area of stock markets. So in the stock market, we want to know how the stocks are performing. We want to know whether or not buying a particular stock, for example, buying 10 shares of Microsoft stock, is going to be profitable for us. So in this case, if we want to know those information, then we use data science to deal with this. And as far as data science is concerned, it is used in different areas, ranging from cybersecurity to sports analytics. For example, like in cricket, for example. So in this case, so if we want to know what is the average betting score of, say, Sachin Tendulkar when he was in his prime, for example, then we could use when he was playing. Of course, I know that Sachin has retired a long time ago. But if we want to know how good he was when he was playing, then we could use data science in order to analyze his betting numbers, the number of wickets that he scored, so on and so forth. So when it comes to data science, there are three different components. So first, we have machine learning. So machine learning goes hand in hand with data science. In addition to that, we have data sets, and then we have precision and recall. So data science consists of these three parts, and we'll be looking at each of them as we move along. So first of all, let's look at machine learning. So what is machine learning? So machine learning is part of data science and artificial intelligence. So what is the machine learning? So if you do a quick Google search on machine learning, you will see a huge collection of articles discussing what machine learning is. Each author has their own way of defining what machine learning is. But for my definition, I would say that machine learning is all about making computers think in the same way as human beings do. Okay? So, of course, we as human beings are quite sophisticated, right? So we could think about the various problems, various issues, depending on the circumstances. However, with computers, unfortunately, Skynet is not with us yet. Okay, so in this case, until we get to the point where we have a Skynet, sort of like the Terminator version of computers, we have to train computers to think in the same way as we do. So this is where machine learning comes into play. So when we talk about machine learning, so machine learning tends to be what is called domain specific. So when it comes to machine learning, so machine learning tends to be focused towards a particular domain. So for example, if we want to create a machine learning model for analyzing cricket scores, for example, then we need to provide our model with data sets of cricket scores, and so on and so forth. So it's usually domain specific, meaning that it is typically limited to a particular sector, be it cybersecurity, healthcare, sports, cricket analysis, so on and so forth. So when it comes to machine learning relies heavily on data sets. So the question then becomes, what is data set? So data set is nothing more than a collection of data. Okay, so when a data set typically consists of hundreds and thousands and millions of records, and it's typically used to train a machine learning model. So what is a model? A model is nothing more than a fancy way of saying a program. Okay, so as we move along, whenever we discuss machine learning, we will always get to see the term model coming up. But the simplest term of what a model is that it's simply a program. That's it. A model in this context is a program that uses a machine learning in order to perform a specific task. So when it comes to a data set, a data set consists of two parts. One is what is called features or classes. So the classes are what we want to predict. So for example, if we want to build a cybersecurity model to detect whether a given set of features is an attack or a normal. So in this case, the classes in this context are going to be attack, if it is an attack, or normal. And in addition to that, we also have features. So the features are what the labels or the classes consist of. So what do I mean by that? So imagine that, so in this case, just a bit of an example. So in this case, imagine that we want to create a machine learning model which detects cybersecurity attacks and normal behavior. So in other words, given a computer behavior, we want our computer to tell us whether this computer is acting normally or it is acting because of an attack. So in this case, the classes would be, if it is a normal, that would be a 0. If it is a 1, it means that it is an attack. So as far as the features are concerned, it will be the features are going to be the characteristics that make up a normal attack or an attack itself. So in this case, the features would be things like the number of connections that are sent to the target, the number of bytes that are sent and transmitted between our target and the attacker, and then also as well as the number of unknown services at the target, and so on and so forth. Okay, so another way of looking at features is if we want to understand what a student is. So the features of a student would be things like his or her student ID, their name, their class, their address, the course that they are taking, so on and so forth. Okay, so those are the features. And the classes would be, if a particular person is a student, that would be a 1. And if that particular person is not a student, then it would be a 0. Okay, so that hopefully this will make sense, but don't worry about it for now. We will clarify it as we move along. So when we talk about data sets, we need to look into what is called a training set and a test set. So given a data set, yes, we use a data set to train a machine learning model or a machine learning program. That's true. But from a data scientist perspective, training a model alone is not enough. Because after training it, we also want to know how good our model is. Otherwise, our model, we can't sell our model, basically. Without knowing how good our model is, how accurate our model is, we couldn't know for sure whether our model is useful to the user or not. So in this case, what we typically tend to do is, given one data set, we break it into two parts. So one is what is called the training set. The training set is a part of the data set that we use for, you guess it, training the machine learning model. And then the test set. So the test set is typically used for us to test how good our model is. So at this moment in time, you guys will be asking, okay, Thomas, having a training set and test set is good and all, no problem. Can we not use the entire data set to train? Yes, you can. But in this case, we run a very big problem of overfitting and underfitting. So if we use all of the data in the data set to train, we suffer from a problem called overfitting. Okay, so overfitting. So what is overfitting? So overfitting is when we use more data than we actually need to train a model. Okay? So to describe it in an analogy, imagine that overfitting is sort of similar to how we deal with our parents, right? So in this case, as you guys know, we love our parents and everything, but every now and then you just find yourself, your parents will be like telling you the same thing over and over and over again. So what happens? The first time is okay, no problem. The second time, still okay, but after like hundreds and thousands of times saying the same, after hearing the same thing from them over and over again, what happens? You kind of ignore them, don't you? The same principle applies. Overfitting is the same thing applied to data science / machine learning. Okay, so overfitting is when we provide more data than we actually need in order to train a model. So the end result here is the model becomes difficult to adapt to changing situation. Okay, so in this case, essentially the model says, you know what, I've seen it all. I don't need to care about it anymore. I'm going to do my own thing. Sort of like how we do when we deal with our parents. Okay, so overfitting is the machine learning equivalent of what happens when our parents tell us the same thing over and over again. Okay, and on the flip side of it, we have what is called underfitting. So underfitting is when we use less data than we need in order to train a model. So the end result here is the model has no idea what to look for. Okay, so to put it in a similar analogy, so underfitting is quite similar to, imagine that, your parents one day has asked you to like go to the store and buy a packet of instant noodles, for example. Okay, so your parents say like, hey, go to this nearby shop to buy a pack of instant noodles. You say like, okay, fine. You get to the shop and you see a huge collection of different packets of instant noodles. You have Mama, you have YY, you have Yum Yum, so on and so forth. Okay, so you have a huge collection of instant noodle brands. But your parents didn't tell you like exactly which packet to buy. So what happens? You end up making an educated guess as to like, okay, so I think they are going to ask me to buy brand A. And then you just bought it and then you come back home. Okay, so if you're lucky, then the brand that you bought is precisely what your parents wanted, but based on my experience, 9 times out of 10, you usually get it wrong. Okay, so underfitting is the machine learning equivalent of that. Okay, so the long and short of it is, in order to avoid either cases, we need to use just the right amount of data in order to train our model as well as to test how accurate our model is. So the question then becomes, okay, Thomas, we now know what data science is, we now know what machine learning is, we now know what the training set and test sets are, and we also know the dangers of overfitting and underfitting. So how do we go about making sure that we don't overfit and at the same time we don't underfit as well? So the answer here is we could use the two metrics that are used quite extensively in machine learning, and they are called precision and recall, which I alluded to early on. So before we talk about precision and recall, I'd like to give a quick example of what they are. So in this case, imagine that we have a machine learning model. Okay, so imagine that we have a machine learning model that can detect human faces within a video file. Okay, so in this case, think of it as a computer vision program that given a video file can detect, human faces within a video. Okay, so for example, if we put in a video clip of, say, Doom, for example, they could detect the actors and the actresses within the Doom movie file. Okay, so in this case, that's a model that we have created. Okay, so in this case, when applied to a video file consisting of 10 people and the number of objects, our machine learning model was able to detect 8 people. Okay, so out of 8 people, and out of the 8 people, 6 were actual human beings, while the other 2 are objects. So in this case, the precision would be, so the precision here is going to be 6 divided by 8. So it would be 6 divided by 10. So that means that out of 10 people in the video file, it was able to detect 6 people. That means as far as the accuracy is concerned, our model has an accuracy of 60%. Okay, so 60%. However, with recall is when we want to look into how many out of the number of people detected, how many of them are actual human beings. So in this case, recall would be 6 divided by 8, which would be 75%. Okay, so 75%. So as far as the precision is concerned, so precision is all about measuring how accurate our model is. So that will be, in our previous example, in the video file, we have 10 people, but our model is able to detect 6 people. So in this case, it would be the number of people, the precision would be 6 out of 10, or if we want to convert it into a percentage, it would be 60%. And as far as the recall is concerned, it refers to how quickly, how fast, or how the fraction of the relevant responses which are obtained. So in our previous example, it was able to detect 8 humans, right? But out of those 8 humans that the machine learning model said it detects, only 6 of them were actual human faces. So in this case, the recall is going to be 6 out of 8. Okay, so 6 out of 8. And then when it comes to measuring the machine learning model, we also have something called the F1 score. So F1 score is basically precision plus recall divided by 2. That's all there is. Okay, so that's all there is to it. So F1 score is the average of precision and recall. And last but not least, we have support. So support here refers to the number of correct samples for each class. So what do I mean by that? Hold that thought for a minute, and we will discuss. I will show you what I mean as we move on to the practical session. Okay. Right. So as far as so far so good. Right. So far we have looked into an overview of cybersecurity, why it is important, what it entails, so on and so forth. We also look into data science, what it entails, machine learning. We also look into the data set, why needed to look into training and test sets, how we go about measuring how good a model is, so on and so forth. So now we are going to move on to our activity. So for our practical activity today, we'll be developing a machine learning model to detect Bitcoin ransomware attacks. So in this case, given a set of features, given a set of network features or network or Bitcoin features, we want to determine whether the network flow is indicative of either a ransomware, or in other words, a cybersecurity attack, or it is just a normal traffic flow. So in order to do that, we'll be using something called clustering. Okay, so we'll be using Python with clustering. And as far as our data set is concerned, we'll be using the NSL KDD cybersecurity dataset, which you can download for free online. And the nice thing about using data science and cybersecurity in Python is that in Python, pretty much every single machine learning algorithm, every single cybersecurity technique has already been implemented. So it's just a matter of you knowing which library to use and which function to call. It is really very, very simple. Even if you have no experience at all, you don't need to implement it from scratch. Okay, so from scratch. So even regardless of your existing Python skills, whether you are a beginner in Python or whether you have some experience with Python, or for that matter, any other programming languages like say C# or C or C++, no problem. Python is extremely easy to learn, and it's extremely easy to get the hang of, so to say. And and the best thing about this course is that throughout your time on the course, we will be on hand to guide you through the process of getting the hang of Python, and understanding how to use it in data science and cybersecurity. So there's no need to worry about it. Okay, so that was what I wanted to touch upon, but back to our webinar at hand. So in this case, this is how our data set looks like. So in this case, in our data set, there are 6 different features. So we have source bytes, destination bytes, count, service count, destination host count, destination host service count, and then we have something called classification encoded. Okay, so what does source bytes mean? So source bytes usually refer to the number of bytes that are flowing from a particular source at a given point in time, the amount of bytes that are being transmitted from a particular source. And this is quite common when we look at a botnet attack, for example, which I'm sure some of you will have heard of. So a botnet is a network of bots, which is basically a computer that has been compromised. Okay, so in this case, given a computer or a device that has been compromised, typically, more often than not, it will start sending a lot of information to the bot master, which controls the entire bots that it has compromised. So in a typical scenario, the compromised computer will typically send a lot of information to the master. And with that amount of information that is sent, the number of bytes that are sent from that typically tends to be quite huge. Okay, so quite huge. And on the flip side of it, destination bytes typically refer to the amount of bytes that are received at a victim. So in this case, whenever a bot master wants a computer to do something bad, it will start sending a lot of information. So when that happens, the number of bytes that a compromised computer receives tends to be quite high. Okay, so source bytes, destination byte, we sorted. And as far as the count is concerned, so count refers to the number of connections that are connected to a victim's machine. Okay, so typically the more a compromised a computer is, the higher the number of connections that you will get to see in number of connections which are established on that particular compromised computer. And as far as service count, or in our case, just for the sake of simplicity, we just set it as service count, which refers to the number of unknown services that are connected to a compromised machine. So typically, as we all know, typically when we look at a normal computer, we have a web connection, which is an HTTP connection or HTTPS connection. For those who are using VPN, for example, those are legit connections. So in this case, those are okay. But when it comes to like attack connections, so they tend to use port numbers that are not normal, etc. So these are the service count the number of unknown services that are connected to that particular machine. And then next up we have the destination host count. So in this case, it basically counts the number of connections sharing the same source, the same single source computer, right? So in this case, think about it. If you are a bot master, if you are the cybersecurity attacker, you want to get control of as many computers as you can, don't you? So the more victim computers that you could control, the more connections, the more likely that your victim computers will be connecting back to you, right? So that you could start communicating back and forth. So in this case, destination host service count refers to the number of unknown services that could be traced to a single source. Hopefully this makes sense. And last but not least, we have what is called classification encoded. So in the original data set, the classifications typically have a specific name, attack name attached to it. But in reality, from a machine learning perspective, we need to change each of these names into a number. The reason why, you might be asking, so why do we have to change it, Thomas? Can we not use the names to understand it? After all, computers are so intelligent. Nowadays, computers can, recognize human beings. We even have like robots running around, right? Like Asimo and so on and so forth. Yes, I agree. But the problem here is at the end of the day, unfortunately, for now at least, computers only understand numbers. Okay, so up until the day where we have a real world version of Skynet and we have Terminators running around, only then we will get to see computers getting more and more intelligent. But for now, at this particular moment in time, the only thing that computers understand are numbers. Okay, so as such, before we go about training a model, we need to first convert the names of these attacks into a numerical form. Okay, so for example, number 7 is a normal traffic, by the way. So in this case, if a computer sees number 7, it says, 7 means normal. And by the same token, if a computer sees the value 5, it means that it is an attack. And with this attack, we have The number of unknown attacks and unknown connections is 123, and out of the 123, 6 of them are unknown, and the number of connections with a common point is 255, and then the number of connections sharing the same unknown connection is 26. So that's what that means. So in other words, if a network flow has these similar characteristics, then the machine learning model would classify this as an attack. Okay, so this is how our data set looks like. And as far as our data set is concerned, for our data set that we'll be using, the number of records that we have are over 23,000. So to be precise, we have 23,512 records. And as far as you guys have seen just now, the number of features that we have are 12. There are 6 different types of features. Because we have 1, 2, 3, 4, 5, 6. We have 6 different features, and the number of different attack types are 12. And this 12 also includes normal traffic as well, because as we alluded to earlier, we want to determine whether or not a network traffic is either a normal or an attack. So in this case, also we need to train our model into learning what a normal traffic flow is. Okay, so this is a breakdown of what our data set is. And before we actually get to our practical session, I'd like to give a quick overview of what clustering is. Okay, so from a technical standpoint, clustering is something that we always do on an everyday basis. So which is where we group items together based on similar characteristics. Okay, so similar characteristics. So clustering simply means grouping things together based on similar characteristics. So for example, imagine that you have a huge collection of comic books. Some of the comics are from Marvel, some of the comic books are from DC, etc. So in this case, if we were to group those comic books together, we would be grouping them based on comic books that are from Marvel in one side and comic books that are published by DC on the other side. So in this case, the number of clusters that we will have will be 2, Marvel and DC. Okay, so that's what clustering is all about. So in data science, we call it clustering, but in everyday terms, we call it grouping. Okay, so that's what a clustering is. But I'd just like to give a quick overview on what a clustering is. So in this case, imagine that we have a collection. So imagine that we have a set of data, and we want to group them into 3 groups. Okay, we want to group them into 3 groups. So the first thing is, before we go forward, we will be looking into the clustering algorithm that we'll be looking at is something called k-means clustering. So you might be wondering, what does k-means mean? What does k in k-means mean? Okay, so k in this context simply means the number of groups that you want to create. Okay, so in our previous example, we have 2 groups. So we have Marvel and DC. So in this case, in that example, the value of k would be 2. Okay, and in this context, so since we want to group these data points into 3 groups, so in this case, the value of k would be 3. Hopefully this makes sense. So coming back to here, so in this case, we have a collection of data points, and we want to group them into 3 groups. So in this case, the value of k would be 3. So first of all, we have no idea how to go about grouping it. So the first thing that we are going to do is we are going to put what is called the center position, the center points randomly. Okay, so randomly, and so in this case, the blue. So in this case, there will be three groups. So one in red, one in blue, and one in green. It doesn't have to be precise at the beginning. So in this case, the way we are going to approach this is any data point that is closer to each of these points will be marked as that color. So in this case, so the closer the data points are to each of these centers, the more the likelihood is that it will be grouped together. Okay, so in this case, this is our starting point. And then as the algorithm approach, as we start executing the k-means clustering algorithm, first of all, as you can see, so since these points are closer to red than they are to blue, all of these are marked as red. And by the same token, points that are closer to blue than green are marked accordingly, so on and so forth. So once we have marked it together, then what we do is we update our center points to be closer to the points that we have identified. So in this case, we have updated our center position. So far so good. So now it tends to be quite relevant. Okay, so as far as the red point is concerned, we're good. Okay, so the red point, the red group is okay. But the problem here is that there are two groups. So in this case, have a look at this green point. Okay, so if you based on your eye test, if you look at the distance between the green point and the blue point, the blue center, and the distance between the green point and the green center, you get to see that the green point is closer to the blue center than to the green center. So in this case, we run the algorithm once again, and then sure enough, now the green point now belongs to blue. Okay, now belongs to blue. And then after everything is said and done, we move it, we update our center points, and now we have our k-means algorithm completed, which at the end of our algorithm, we do have got three groups of data points. Okay, so hopefully this makes sense. And so as far as our practical session is concerned, this is what we want to achieve. Okay, so this is what we want to achieve. So in this case, we want to look into, so in this case, for our practical session, since we've already trained it, the accuracy of our model is 97%, which is a very good model as a starting point. Okay, so starting point. And as you can see, so in this case, we have for each of these classes, we have a precision, recall, F1 score, and then we have support. So in this case, the support here basically indicates the number of correct samples that belong to each of these classes in the correct prediction that our model has produced. Okay, so for example, as far as the attack, for example, 5.0 is concerned, it is able to achieve an accuracy of 97%. Okay, so 97%, and which means that if we run, so in this case, whenever it sees 100 different network flows, it is able to detect correctly 97 of them correctly. And out of these 97%, 1,616 features are correctly classified as such. So that's what we want to achieve. Okay, so with that said, let's look at our practical session. So before we do that, so in this case, so as I alluded to earlier, Python is the best thing about Python lies in the fact that it is super easy to learn and it's super easy to use. Not to mention the fact that pretty much every single machine learning algorithm that we could possibly imagine, be it k-means clustering, logistic regression, support vector machine, etc., it has already been implemented. It's just a matter of you knowing, one, which library to use, and two, which function or which method to use. Those are the only two things that you need to know. Okay, so before we go into the source code, I would like to show you how it is going to run. Okay, so in this case, if I run our Python source code, our k-means clustering source code, if we run it, so in this case, first of all, we want to know how our data set is, right? So how our data set is, how many classes are there, so on and so forth. So first of all, so in this case, there are 13 different types of features. There are 13 different types of classes, and the one in pink is the normal traffic flow, the normal traffic features. So in this case, the remaining are the different. So the rest of them refer to the different classes of attacks. So just quickly, for the sake of this example, Nmap. So Nmap is a cybersecurity tool that is typically used for scanning. Used for port scanning, meaning that given our target, we want to know what ports are open, what web applications are running on our target, what kind of services are running, so on and so forth. So in order to get to know more about the target from a port application standpoint, we typically run Nmap. So as you can see, we have a few connections that could be classified as an Nmap, which by itself is a form of attack. And in addition to that, we also have Neptune. So a Neptune attack is what is called a DDoS attack. So a DDoS attack doesn't steal information, doesn't take anything out of our target, but rather we make our target useless. Okay, so we essentially make the website that is running on our target unusable. And last but not least, we also have Where's Client. So Where's Client is a form of botnet attack. Okay, so the botnet attack. So a compromised machine will run a Where's Client, and that client is responsible for sending information back to the bot master, which will be running, you guessed it, the web's server or the Where's master application. So before we go about doing anything else, before we go about building the model, the first thing that we want to do is we want to know basically what our data set is up. What's up with our data set? Okay, so this is our way to go about doing it. And next up is going to be our histogram. So in this case, as you can see, it's fairly similar to what we have seen just now. So now we want to know how many traffic flows we have. So in this case, as far as our normal flow is concerned, we have a little over 13,451. And the rest are all the various forms of web-based attacks. Okay, so this is how, so after everything is said and done, this is how we go about training it. So as far as our model is concerned, our model is currently able to achieve an accuracy of 97%. Okay, so this is what our program looks like as their output. So now let's look at how we go about programming it using Python. So now in order to do that, let's have a look at our source code. All right, so here what we have here is we have our Python source code. Okay, so step one. First of all, before we go about doing anything else, the first thing that we are going to do is going to be to import Python libraries. So as I alluded to earlier, the best thing about Python is that it has got all the libraries and the packages available, but we need to call them appropriately. We need to import them appropriately. So first of all, we need to import pandas and NumPy. So for those who have some sort of experience in Python will know pandas and Python are used for reading data sets from CSV files, performing numerical processing on numbers. So first of all, we are going to import pandas and NumPy first. And next up, we are going to import the scikit-learn. So scikit-learn is a Python library containing all these different types of machine learning algorithms, which means that you guys have no need to implement this from scratch. You can just call them appropriately, so on and so forth. So in this case, the first scikit-learn library module that we are going to import is going to be the pre-processing. That means from a data science point of view, before we go about training a model, before we go about doing anything that is fun, what we need to do is we need to perform what is called pre-processing. So that means that we are going to remove data that is empty. We want to remove empty columns. We need to make sure that all the features are represented fairly, etc. So in order to do that, we need to first perform data pre-processing. Otherwise, our machine learning model will have no idea how to go about understanding our data set. Okay, so until we get to the point where the computer is able to understand it automatically, this is what we have to do. So next up, the next Python module that we are going to import is going to be train test split, which, as you remember from our lecture just now, is all about splitting our data set into training set and test set. Okay, so in order for us to achieve this, this is what our function is going. This is what this module or this method is. And then next up is going to be confusion matrix. So the confusion matrix is what is used for measuring how accurate our trained model is, and is used in conjunction with classification report, which will give us this report showing us the precision, recall, F1 score, accuracy, and all the good stuff. Okay, and then next up, we are going to import our libraries themselves. So in this case, since we are going to be using k-means clustering, we are going to import the k-means clustering algorithm, which is available in sklearn.cluster module. Okay, so sklearn is the technical term for the scikit-learn library. So as human beings, what we call scikit-learn is what the computer understands to be sklearn. So in this case, we need to tailor our language accordingly. Okay, tailor our language accordingly. So that's where it comes from. And then last but not least, and before we get to the actual good stuff, we need to import the libraries that we will use for visualization. So when we talk about visualization, it's a fancy way of saying we are going to generate graphs that we saw just now. So in order to generate the graphs that we saw just now, we are going to import the matplotlib library. Okay, so matplotlib library. So the matplotlib library is a collection of modules that allow us to create all different forms of all the different types of graphs and charts and tables that we could ever ask for. Okay, so the bar chart that we saw just now is just a very small example of it. So you could use matplotlib for line graphs, bar charts, cluster graphs, so on and so forth, or even box plots for that matter. So before we move on, so 3 things that we have done. So 1, we have imported NumPy and pandas for numerical processing. 2, we have imported the different modules in scikit-learn for machine learning. And 3, we have imported matplotlib for generating graphs. And last but not least, we are going to import joblib. So the joblib library is responsible for saving our machine learning model so that we could use it when we could use it for next week when we actually use it to detect cybersecurity threats in real time. Okay. So in this case, so first things first. So what we have done here is step 2. So first we import the libraries that we need, and step 2, we load the data set. So in this case, in order to loading the data set means we are reading the data set. So in order to read the data set, we are going to use the read_CSV method from pandas. So this method allows us to read the entire CSV file from and all of its contents from the file, and then we are going to put it into a variable called PD_ransomware. Okay, so as the name suggests, this is going to be the variable containing all of the data sets, all of the features that we have read from our data sets. However, this data set is not perfect. Why? Because at different points within the data set, we've got some of the rows are empty, some of the rows don't have any numbers at all, so on and so forth. So before we go about doing anything else, what we are going to do is we want to drop any empty columns, empty rows, so that it makes it ready for use for training. Okay, so ready for use for training. So in this case, in order to do that, we are going to use the method called dropNA. Okay, so dropNA. So the dropNA is a Python pandas method that allows us to remove any rows and columns which are either empty or are corrupted. So in this case, since we want to remove empty rows, the access ID in this case will be a 0. However, if we want to remove a zero values from columns, so in this case the access would be 1. So in other words, 0 for rows, 1 for column. And then as far as how it's concerned, we are not just going to remove any columns that are only got 0 values, but we also want to remove any rows that are empty, 0, etc. So that's why we have specified it as any. Okay, so first things first. So in this case, so far we have loaded our data set into this PD_ransomware variable, and then we have cleaned up. Okay, so we have cleaned up all of the data, all of these. So in this case, we could say that this is part of data preprocessing. Okay, so data preprocessing. So in this case, we remove any empty or 0 rows from our data set, and then before we do anything else, we want to see the first 5 entries of our cleanup data set, and we also want to see how our data set looks like. So in this case, we run this, and this will give us the first 2 results. So And then we want to know, so in this case, we want to know how many, so in this case, we want to know what are the first 5 entries of our data set, newly cleaned up data set are. So in this case, we run pd_ransomware.head. So it will show us the first top 5 entries of our data set. Okay. However, on the flip side, if we want to see the bottom half, the bottom 5 entries of our data set, all we really need to change is to change it from head to tail. That's it. Okay. So as you can see, it's fairly straightforward, right? So if you want to see the first 5 entries from the top, we use pd_ransomware.head. If we want to see the first 5 entries from the bottom of our data set, we just simply change it from head to tail. Okay. And then this will give us the first 5 entries of our data set. Okay, so as you can see, the first 5 entries would consist of 4 normal traffic and 1 attack feature. Okay, so hopefully this makes sense. And in addition to that, we also want to know how our data set is distributed. We want to know, what is the maximum traffic flow, what is the maximum number of source bytes. We want to know what the maximum number of destination bytes. We want to know how many connections that are connected, unknown connections that are connected to a target, so on and so forth. So in this case, in order for us to know that, we are going to use this describe method from Panda. So in this case, if we run pd_ransomware.describe, it will show us precisely how our data set looks like. Okay, so as you can see, so in this case, we have different calculations. So in this case, count. Count here means the number of records that we've got. So it is correct. So in this case, as far as the number of records that we have on our data set is concerned, there are 23,512 records. And then, in addition to that, we have mean. Okay, so mean on average. So on average, the number of unknown connections that are taking place at the destination compromised machine is right about 187. Okay, so out of this approximately 187 connections, we have about 115.3 that are unknown. And as far as the average number of classification is concerned, is right about 6.45, which basically tells us that we have a good distribution in terms of the number of normal traffic, normal computer behavior, as well as abnormal computer behavior. And then we also have the standard deviation. We also have the minimum. So as far as the minimum is the minimum value. So minimum value means the smallest value for each of these features. So for example, in this case, the minimum number of connections at a particular target at any given point in time is 1. Okay, and typically out of this 1 connection, the minimum number of unknown connection is 0, which means that connection that we have just detected, it is a known connection. In other words, it is a legit connection. So that's what that means. And then on the flip side, we have the maximum values for each of these columns. So in this case, for classification encoded, the maximum classification value is 12. And this is correct. Why? Because, as we discussed earlier, there are 12 different types of classes. Okay, so hopefully this makes sense. So it's all about, so when it comes to data science, we could leave it to Python to do all the hard working for us. As far as we are concerned, it's all about understanding what the results are saying, and then that's what we'll be looking at on our course on data science and cybersecurity. Okay, so let's go back to our code. So in this case, so before we do that, we also want to know the distribution. So in this case, yes, so far we managed to see all these numerical values, etc. But we also want to get a visualization, because I don't know about you, but for me, I'm more comfortable looking at the charts, because with the charts, you got the colors and we got the bar charts and etc. So it kind of gives me a much better overview of how our data set looks like, what the distribution is, so on and so forth. So in order to do that, we are going to use something called the cross tab. So in this case, cross tab simply means cross table. So for those who are familiar with Excel, you could think of this as pivot table. So in other words, what is pivot table in Excel is called cross table in Pandas. So in this case, we are trying to do is we want to create a small pivot table containing the number of traffic, count, and the classification encoded, and we are going to plot it as in the form of a bar graph. Okay, and then the title of our PLT, our graph is going to be traffic count by attack type, and our Y label is going to be listed as traffic count, and our X label is going to be called attack type. And then once we have set all these parameters, we are going to display our chart by calling the show method, so which will give us, so if we run our k-means clustering again, which will give us this graph. Okay, so this graph. So in this case, we have, so in this case, we have the classification encoded on the x-axis, and then we have the traffic count on the y-axis. So as you can see, the title for our graph is going to be traffic count by attack type, which is precisely what we have typed here just now. And then for our label, for our Y label, we have traffic count. We specify it as traffic count here, which give us this. And then as far as the Y label is concerned, bottom here, you will, because our site is quite huge, we won't be able to see it, but please believe me when I say that there is a string called attack type on the x-axis. Okay, so the point I'm trying to make is I want to show you guys how each of these correlate to each of the features in the graphs. Okay, so this is our second graph, which is a histogram. Okay, so which is defined by this. So the reason why we are seeing this histogram is because of this his method that we have called. Okay, so in this case, we want to know how the distribution, the histogram of the classification encoded column. So in this case, we want to know how many features are normal, how many features are Nmap, how many features are DDoS, so on and so forth. So in this case, this is a histogram, and the reason why we are seeing this histogram is because we are using the his method of the PD ransomware, whereby the column that we are interested in is the column name called classification underscore encoded. Okay? And then in order to show whenever we want to display our chart all we need to do is call the show method from matplotlib. Okay, so far so good, right? So far, step 1, import the libraries that we need. Step 2, read the data set and perform data pre-processing. Step 3, perform visualization. And along step 2, perform visualization as well. So step 3 and 4. Step 3 and 4, from steps 3 to 5, or by extension, step 6. From steps 3 to 6, we are actually going to now start training our machine learning model. Okay, so first things first. In order for us to train it, first we need to extract our features and our classes first. So in this case, we are going to so first of all, we are going to extract from our PD underscore ransomware variable, we are going to extract columns 0 to 6, which are essentially the features, if you remember our screenshot just now. And then we are going to extract the first 6 columns because they are features, and then we are going to convert them into a NumPy array. Why, you might be asking? The reason why we need to convert our Panda dataset, our Panda features into a NumPy array is because scikit-learn only accepts data types that are of a NumPy array. Okay, so it doesn't accept a Panda data frame. So in order to make scikit-learn happy, we need to convert it into a NumPy array. So long story short, first thing we are going to do is we are going to extract the first 6 features, convert them into a NumPy array, and then put them into a variable called np underscore ransomware features, where np means, you guessed it, NumPy array, NumPy. And then the next step is going to be, once we have extracted the features, now we are going to extract our labels, or we are going to extract our classes. Okay, so in this case, into a variable called malware labels, we are going to extract the final column, the last column in our Panda data PD underscore ransomware data frame. We do the same thing, we do the same step as we have done here, convert it into a NumPy array, and then put it into a variable called malware labels. Okay, so as things currently stand, we have extracted our dataset features and we also extracted our classes. Okay, so that's good. Now, in step 4, we are now going to break the data set into training set and test set. So in order to do that, we are going to use the method called train test split. So the train test split is a scikit-learn method that allows us to split our features and our classes into training set and test set. Okay, so training set and test set. So in order to do that, so as you can see, there are 4 variables here. So we have xtrain, xtest, ytrain, and ytest. So xtrain and ytrain are fairly self-explanatory. Okay, so those are the features and the labels that will be used for training our k-means clustering model. And then xtest and ytest are going to be the features and the labels that we'll be using for, you guessed it, testing. So in order for train test split to work, there are 4 parameters that we need to provide. So first of all are the features, which we have obtained from here. And the second argument is going to be the labels, which once again we've obtained from here. The interesting part about this is going to be the test site. So in this case, we need to specify what percentage of how much percentage of our data set we are going to reserve as our test site. So in this case, notice that we have set it up to 0.2, which basically means we are going to allocate only 20% of data set for testing. So in other words, we are going to use 80% of the data set for training, which is sometimes called the Pareto's principle. Okay, so on the flip side, if we want to use, say, 70% of the data set for training, then we could change it to 0.3, because 70% for training, remaining 30% for testing. But for now, good rule of thumb is, a good general rule is that we need to use 80% of our data set for training, with the remaining 20% reserved for testing. And the final parameter argument that we need to provide is going to be random state. So you might be asking, so Thomas, what does random state mean? So in this case, that's a very good question, by the way, and it certainly is worth exploring. So the reason why it is because when it comes to k-means clustering, it is a randomized, random-based, it's random in nature. So in this case, what typically tends to happen is, without specifying the random state, without putting a hard value on the random state and a number, the results that we get will typically vary slightly with each run. So in this case, if we run it for the first time, if we run it 10 times, the results that for example, if we run this same program for 10 times, the results that we will get in each of these 10 times will be slightly different if we don't set the random state to a fixed numerical value. But from a data science perspective, we don't want any randomness at all. Meaning, whether or not we run it 10 times, we run it 100 times, we run it 100,000 times, we want to make sure that we get the same results. Okay, so in order to make sure that that is the case, we put it a fixed numerical value. So in this case, as far as the number is concerned, we could set it to any number that you want. If you want to set it to 12, that's fine. If you wanted to set it to 31, that's fine as well. But in my case, I've set it to 42. Okay, so which is a reference to a well-known movie called The Hitchhiker's Guide to the Galaxy, which is a sci-fi novel. Okay. And then once we have extracted the features and the labels, and we have broken down our data set into training set and test set, now finally we are going to build our machine learning model. Okay, so machine learning model. So in order to do that, we are going to use yet another scikit-learn's method called k-nearest classifier. And then, in this case, the number of neighbors here, in this case, we talked about this just now, is going to be 12. Why? Because there are 12 different types of labels, and we want to group each of the label appropriately. So in this case, the number of labels is going to be 12 in this context. And then in order to train a model, all we really need to do is we need to use the k-neighbors classifier function and then use a method called fit. And then into this function, we pass two arguments, xtrain and ytrain. That's all there is to it. It is simple, isn't it? So in everyday terms, like when you go about reading different machine learning articles and such and etc., people make such a big deal about training a model, like training a model training a model, training a machine learning model. But when from a Python perspective, it's just a matter of calling the appropriate machine learning algorithm and then calling the fit method and then passing the training data appropriately. That's all there is to it. Seems simple, doesn't it? So after this, once this function has been executed, now we are going to test our model. Okay, so test our model. So in order to test our model, what we are going to do, you guessed it, we are going to use our test data. So in this case, we are going to, first of all, we want to see how accurate our model is. So in this case, we are going to use a method called score. Okay, so it will give us a score, an accuracy score, using the test features and the test classes. And then we are going to print out the accuracy score here, and by doing that, we are able to see our accuracy report here. Okay, so according to our accuracy report, we have an accuracy score of 97%, rounding nearly 97%, which is a very good result given the size of the data set and the number of classes that we've got. So in this case, now finally, no, not exactly finally. So now what we want to know is we want to know our classification report. So when we talk about a classification report, the classification report tells us the precision, recall, accuracy, and our F1 scores, amongst others. So in other words, it tells us precisely how good our model is. So in this case, in order to do that, there are two steps to it. So first of all, what we want to do is we are going to pass our testing features. We are going to pass our test features into our model and let it predict. Okay, so let it predict, and then we are going to get the results, the prediction results, whether it is an attack or DDoS or botnet or Nmap, whatever. Predictions into a variable called knn_predictions. Okay, so predictions. And then we are going to use a method called classification report. Classification report, and then into the classification report, we are going to pass two arguments. So it's going to be y-tests. So because we know, so y-tests are the correct values. Okay, so correct values belonging to x-tests. And then we are going to compare it with the predictions that are predicted by our model. So in other words, the classification_report method is used for comparing how accurate our predictions are against our correct labels. That's all there is to it. It's all about comparing the predictions against our correct labels. So the more correct the prediction results are, the more accurate our model is. Make sense? Hopefully it does. And then after everything is said and done, we are going to print out our classification report, which will give us this classification report. Okay, so as you can see, the accuracy is the same. So albeit it kind of rounded up. In this context, the value got rounded up to 2 significant decimal places. Okay, so as such, it is classified as 0.97%, but you'll get to see that they are basically the same. And as far as the precision values are concerned, precision value numbers are concerned, it is able to classify each of these classes appropriately. Okay, so as you can see, so for example, in this 10th time in this class called 10th, which is a DDoS attack. Okay, so in detecting a DDoS attack, the precision value for this was 77%. Why, you may be asking? The reason why was because there are less number of training features that belong to, in this case, the DDoS attack. So in other words, in order for us to increase the value of precision here, we need to make sure that we provide our model with the appropriate number of DDoS features. However, on the flip side, our model is able to achieve a 99% accuracy in detecting normal attacks. Why? Because we have provided it with just the right amount of normal attack features. So in other words, in order for us to improve upon this, we need to make sure that the number of DDoS features is right around 1,000 feature mark. Okay, and then when everything is said and done, we are going to save our model into a file called knnmodel.pkl. So PKL stands for pickle. Okay, so pickle, which is a JSON file that will contain the details of the parameters. So that during our webinar next week, we don't need to do the whole thing all over again, and then we could simply just read our model and then use it for testing. We use for detecting cybersecurity threats in real time. So as far as this is what our source code is and before we, so in this case, I'd like to show you guys how looks like. Let me run our program one more time. So in this case, let's run it by typing Python 3 kdd_kmeans.py, enter. So in this case, we got our graphs here. So we have, this is the normal traffic features. We have as well as the different types of features. And then we have our histogram of the different forms of attacks and their distribution. And then we have our accuracy value. We have our accuracy score as well as our classification report. And then if we type in ls star.pkl, you get to see that our model has already been stored. So if we look at the contents of the what our model contains, it is a binary file, unfortunately, but we could use it when next week rolls around in our next week webinar, when we look into detecting cybersecurity threats in real time. We can simply load the model into our program without having to train our model all over again. So hopefully this makes sense. So as far as our first of the webinar is concerned, that's pretty much it. So before I let you, so in this case, this is part of our webinar. This is part of our webinar into our course, focusing on looking at data science. So data science for Python, data science and cybersecurity using Python by CreArt. So this is our first time offering in India, and it's designed to provide students with hands-on knowledge and experience, or in terms of getting them up and running in terms of using Python for data science, and applying, and how to go about applying them in a cybersecurity context, ranging from monitoring cybersecurity attacks, detecting cybersecurity attacks, all the way to mitigating cybersecurity attacks. So this course is designed to help folks who are interested in establishing a career in the field of data science and cybersecurity to up and running. So in this case, regardless of whether you are a beginner in Python, or whether you are you have some experience with pre-existing experience rather with programming. There's something for everyone. So each of the way our course is structured is that it will be a combination of lecture and as well as practical sessions. And then at the end of each session, you will get to apply them hands-on in a real-world case scenario. Okay, and the best thing about this course, the way we have structured it, is that you guys can get to learn from industrial experts from the UK, all in the comfort of your own home from India. Okay, so that means that all of the experience that we have gained from my research expertise, as well as my industrial experience, and you could all learn all about it, all about how to go about applying data science and Python in cybersecurity, all in the comfort of your all in the comfort of your own home. And at the end of, so in this case, as far as our course is concerned, we will be structuring it in terms of beginner, intermediate, and advanced. And at the end of the entire course, for those who wish to who want to work for any of the large IT companies internationally, not just in the UK, but also in the US, Canada, around the world really. We will also provide support for any of you guys who are interested in working in an IT / programming / cybersecurity positions that are widely available across all the large companies around the world. Okay, so around the world. Okay, so in this case, so if you have so hopefully, so in this case, hopefully it makes sense, and it was really great getting to share my expertise and experience in cybersecurity and data science in our first webinar today. And any questions and any feedback, please get in touch either using our email, which is going to be online@creart.in, or alternatively, please get in touch through mobile or WhatsApp at this number. Okay, so it was great to have this webinar, and I'll see you guys in the webinar next week. Stay safe, everyone, and bye.